Alright, let's look at the homework 10.4, problem number 9. Alright, so we want to find the arc length of the curve. Alright, so first I'm going to sketch this picture using GeoGebra. Alright, so first I'm going to define our function. So I'm going to call it r of x is equal to cosine squared of x over 2, right? Then hit enter. Right, so we have r of x defined, and I'm going to actually click on this circle so that we don't have to see it. And then I'm going to use a slider, and let's see, I'm going to just use a is fine, and I'm going to do, say, let's see, 0 to 2 pi maybe. Alright, then hit enter. Alright, then I'm going to draw a curve. So curve, then x would be r of t cosine of t. Then y would be r of t sine of t. Parameter is t, and the starting value is 0. And the ending value, I'm going to use a so that I can change it later, right? Then hit enter, right? So here's the curve, right? If I change the value of a, so you can see that it's going to have a shape like that. So this is pi right here. And then I'm going to go all the way to, right, 2 pi to finish it, right? So it looks like to go all the way around, we're going to go from 0 to 2 pi, right? So that's the interval. All right, so let's find the arc length. All right, so first I have to find the derivative. So r prime is equal to, I put 2 in front, keep the cosine of theta over 2. And the times the derivative of cosine is going to be negative. I'll put the negative sign in front. Sine of theta over 2. Then another chain rule, multiply by derivative of theta over 2, which is 1/2. Alright, then we can cancel 2 on top and a 2 on the bottom. So this is going to be simply negative cosine of theta over 2 times sine of theta over 2. Alright, so let's look at this expression. Right, arc length element is going to be, right, square that, so you have a cosine to the 4th of theta over 2 plus, right, we're going to have to square that, so that's going to be cosine squared of theta over 2 and the sine squared of theta over 2. Alright, then I'm going to pull out the, let's see, cosine squared. Right, so square root of cosine squared would be absolute value of cosine of theta over 2. Then what's left is cosine squared from here. And the sine squared. Theta over 2. Alright, then luckily we know that cosine squared plus sine squared is equal to 1. So therefore, this is just going to be absolute value of cosine of theta over 2. All right. So let's, oh, actually, I forgot to put the d theta at the end. Sorry about that. So we have a d theta here and d theta. All right. So if you want to find the arc length, say L, this is going to be integral from 0 to 2 pi to go all the way around. Right? Then you have absolute value of cosine of theta over 2 and d theta. Right? Then if you use the symmetry, you can see that here, this is halfway, right? And this is the other half. So we can just go halfway. The other half is symmetric, so we can just multiply by 2. Right? So instead of doing that, I'm going to do a multiply by 2. Then I'm going to go from 0 to halfway point. All right. Since if theta is between 0 and pi, cosine of theta over 2 is going to be always non-negative. So we can actually take out the absolute value sign. All right. Then find the antiderivative. So we have a 2 here. Antiderivative cosine of theta over 2 would be sine of theta over 2 divided by 1/2, which is the same thing as multiply by 2. Right? Then you're going from 0 to pi. Right? And the first thing I would do is I'm going to just combine 2 and 2, so I would just put 4. So this is going to give us 4 times. All right, sine of pi over 2 is 1 minus sine of 0 is 0. All right, therefore, we get 4. All right, so the length of this arc is going to be equal to 4. All right, let's type it in. All right, we got 4 there. All right, let's submit for testing. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.